Formations. Listening to our stupid conversation.
You actually named exactly what those are called.
Oh.
Popcorn?
The food, I get it.
Yeah, I told you. You'd be right about 90% of the time.
Wow.
So, as we went through, very narrow, but also quite well designed, so to speak.
Yeah.
Is it uplift that causes that? What's the geological process that causes that?
So, you have very good eyes, good observations. And I usually don't highlight this until later.
Okay.
However, no, that's perfect because it's fresh in everyone's mind. Do you guys agree that that was a nice narrow passageway that has a very distinct, defined angle to it, right?
Right.
So, all of our caves here, you couldn't really notice it in Hanson because you only saw the one room. Now you've traveled along most of this cave's linear distance, and then Timpanogos Cave as well. All three of our caves are formed on fault lines. So fault lines are essentially, in the simplest form of the way, big cracks in the mountainside, where two rock masses have movement on one side to the other. And so those cracks were here before the caves existed. And what loves to travel along big cracks in the mountainside? Water. And so water forms the caves, so those cracks essentially funneled all of the water into these spots and dissolved away caves here. And so that's why you guys walk through a nice narrow passageway with a little bit of angle because the fault was at that angle. Okay. And it just got dissolved away from the inside out. And so very apparent now that I've explained it to you in that passageway. Timpanogos Cave, you're going to notice it as well. But the angle is almost 45 degrees, and it's kind of cool to see. When you kind of look back at the whole thing, you just go, wow, it's very easy to see. So that's a really good observation.
So assuming middle cave, it's at a different angle, is it fair to assume that that's a different fault?
Yes, we have tons of faults in these mountains. These caves are actually all on 3 on separate faults.
Okay.
And then there are tons and tons of little tiny faults around the bigger faults. So, but essentially the biggest cracks in the mountain were the ones that funneled the most water to them and dissolved away. So, and we actually think that the water didn't come from above to form these caves. We think most of the formation of this open space we're in now occurred whenever all of this was underwater, deep in the earth, never exposed. There was no mountainside, no American Fork River or anything, and geothermal water found the crack and came up. Because things like this in this room, you notice are very big. And if it was just water coming down, it probably would have stayed into a narrow crack. But here we actually have evidence of geothermal formation that we get to see in other caves. And so this big open ceiling here,
no bats.
which you get to see in other caves, yeah, there are no bats.
I want bats.
But we think that water basically was swirling here. And so geothermal water mixing with regular water was swirling, creating this. You see that happen in other caves where the water is running through streams and rivers, swirling around making potholes. Here on the wall, I usually don't point it out, but you see channels here on the wall. So imagine hot, high pressure water coming up, carving what are called bubble trails. And that's what a lot of these are, were bubbles. They got turned into rock over time as they just deposited a little bit there and then grew and grew. And so these were channels where the hot pressured water would come up, hit a spot that was more resistant, take over, and then keep coming up. And finally it came up here and swirled.
Do you think all this got flooded in the ice age when it was all melting?
So we think that this cave is at maximum maybe 1 million years old, which puts us right in the middle of the big ice age, the Pleistocene era. And so that was when we think this cave was forming, so that's when that geothermal water would have been forming it.
So it was all flooded?
Yeah, oh yeah, this whole thing was underwater. It was probably hundreds, if not a couple thousand feet underneath the ground level.
Was it still called Bonneville Lake back then?
Bonneville Lake was only a few 10,000 years old.
Okay, so it's not
Bonneville
the same
Lake,
water.
Was very young compared to that. And so, yeah, Bonneville would have been very young. We don't really have any evidence of anything from Bonneville making it in here. We have some river sediments that are in the cave and river rocks from the American Fork River whenever the river and the cave entrance for Timpanogos Cave were the same elevation. Before the mountains rose up, which they're currently still doing today, centimeters at a time in a year, and then the river cut down. And so eventually it got 1,100 feet difference, but at a certain time they were together, and that river would flood river rocks in. And we have those on the wall in Timpanogos Cave, which I will point out when we get there.
Okay, I've been on this tour several times and I never heard that.
The bubble part.
That is, I haven't told it before. That is because,
That's really interesting.
It's because
Yeah.
your son asked good questions.
yes, if you ask geology questions, you got the geologist, you're going to get geology answers. So, yeah, so like all of us know these things, but we could sit in here for probably 2 or 3 hours with a tour group and tell you, and we still would have more things to tell you. So we have to kind of narrow it down to things to get you in and out in an hour.